Today I'm Jeff Baumgartner with Light Reading Cable. I'm pleased to be joined by Jeff Finkelstein with Cox Communications. And here at the show, Docsis 3.1 is the big news. Work is obviously well downfield here. And one of the things about Docsis 3.1 versus 3.0 is you're kind of moving from 6 megahertz channels to OFDM and this new like super wide channel capability. So can you kind of walk us through the differences and the benefits of that?
Well, to start with, there's a lot of exciting things going on with Docsis 3.0. For example, we now have full band capture devices where you can place the QAMs anywhere in the spectrum rather than being limited to a 100 or 200 megahertz wide block.
Yep.
So that really does help Docsis 3.0 get a little bit further along. So with Docsis 3.0, the devices coming on board basically now, coming out these days, are 24 by 8 bonding modems where you can bond 24 downstreams, 8 upstreams. Basically, it's about a gigabit downstream and 300 megabits upstream.
Right.
So that gets us a long way down the road. Now, we recognized in some of our discussions from a few years ago that at some point we are going to need more spectrum. So for the spectrum that we need, do we look at bonding even more channels, 32, 48, maybe beyond on the downstream, maybe 12 or beyond on the upstream, or do we look at something totally different? So we did an analysis and had many months of discussion and came to the realization that there is already a modulation technique out there that really advances the technology, and that is OFDM. So with OFDM, rather than bonding at the MAC layer with many 6 megahertz wide carriers, you actually bond at the physical layer with many small sub-carriers. So this way, you actually simplify it at the MAC by not forcing yourself to have to deal with it and deal with statistical multiplexing. You're now doing it at a much lower level, which gives you some optimizations. Because with those smaller carriers, you don't have to deal with a lot of the impairments that you had to worry about before.
Okay. So it's much easier to deal with, and you get some efficiencies, right? So what kind of efficiencies are you looking at with Docsis 3.1, using this approach?
So by using the smaller carriers and taking advantage of some newer modulation techniques, which take us into actually the 1K and even the 4K range, so 4K QAM versus the 256 QAM of today.
Okay.
Much more capable, much more bandwidth. You also can move to a more advanced encoding scheme such as LDPC versus the Reed-Solomon that we've been using so well for so many years. With LDPC, we actually gain back a significant amount of dBs or decibels, which gives us a better signal-to-noise ratio, which is what enables these higher order modulations.
Now, as you start to roll out Docsis 3.1, we still have a lot of 3.0 out there, so how do you see those two technologies either being coexistent or maybe being backwards compatible?
We're considering a number of different options. So one is holistically just Docsis 3.1, and everything has to be Docsis 3.1 that comes out of a given device, and it will only talk to Docsis 3.1 end devices. The other is a hybrid model, where you could have a Docsis 3.0 downstream and a Docsis 3.1 upstream, Docsis 3.1 downstream, Docsis 3.0 upstream, or it could be all Docsis 3.0 or all Docsis 3.1. The reason is that for Docsis 3.1 to coexist, we are either going to have to find a lot of spectrum for Docsis 3.1 to work in, or we are going to be able to slowly add Docsis 3.1 spectrum over time by, for example, taking advantage of analog reclamations, moving more digital broadcast to switch digital, and doing it one step at a time. So it really makes that migration strategy much simpler when you're able to do it by coexisting with existing carriers.
Well, thanks for your time, Jeff. Appreciate it, and walking us through the initial steps of Docsis 3.1.
My pleasure. Thanks, Jeff.
Thanks.